Hey guys, today I'm going to teach you how to identify functions. By the end of this lesson, you'll be able to determine whether or not tables, ordered pairs, graphs, and equations represent functions. So go ahead and get your binder, turn to the math section, and let's get ready to take some notes. Let's start out today by talking about relations. A relation shows a relationship between two things. Usually we see that as x and y, so we can see these as ordered pairs, so you'll see them in little maps like this, tables, graphs, and even equations. In both relations and functions, you'll see x and y being called a few different things, one of which is domain and range. Domain is always your x, range is always your y. You'll also see x and y called input and output. Input is your x, output is your y. All of these are examples of a relation because they have an input value that is assigned to an output value. But today, we're going to focus on functions. A function is a special type of relation. And there's one big rule you need to know about functions. This is the rule. In a function, every input has to have exactly one output. In other words, every x value needs to have exactly one y. If an x value has more than one y value, it's not a function. So that's all we're doing today is identifying functions. So if we have a table or an ordered pair sequence, we're just going to make sure that every input has exactly one output. Let's look back at the first examples of these three relations, and let's determine if each one of these is a function just by following that definition. For it to be a function, every input has to have exactly one output. So in the map, -4 has one output, 2 has one output, 0. But 3 is what makes this not a function because it has two outputs. So while this map is a relation, it does not show a function because it has an x value that has two y values that are different. Let's look at the table. We're just going to test our inputs. So we're going to go down the line, look at each input, and make sure it has exactly one output. The problem is here. Once again, the 3's have two different matches, and that's not going to work for this. So that's how we test tables and ordered pairs. We make sure that every input has exactly one output. We can do the same thing for graphs, but there's another really visual way to test whether a graph represents a function. That is with the vertical line test. So this is a vertical line. You're going to need one. You either have to use your pencil or your finger, and it needs to look like this. It needs to be vertical. What you're going to do is you're going to pass it across your graph moving left to right. It should intersect the graph at exactly 1 point. If it intersects at more than 1 point, it's not a function. So here's how you perform your vertical line test. You start on the left side of your graph. I'm going to use this pink line, and I move left to right. It can only touch 1 point at a time. So right there, it's good. Right there, it's good. But the problem is right here at 3. It's touching 2 points at the same time. It means it has failed the vertical line test. It is not a function. So let's start identifying some functions in some different forms. You're going to see tables, graphs, equations, ordered pairs, all these different types of things. And we're just going to start with number 1. How do I determine if this table is a function? So I need to make sure that every input has exactly one output. But which ones are the inputs? In a function, you put in an x to get out a y. In this table, you have 5 different inputs. Each one has their own output. We're good. So this is a function because every input has exactly one output. A lot of people make the mistake of thinking this is not a function because of these 2 points here. Both of these points go to a 7. Here's how I can show you that this is actually a function. I want to compare this to the NCAA men's basketball tournament. Every year of the tournament, there is one winner. So 2009 there was a winner, 2010 there was a winner. Every single year there's just one winner. However, what you'll notice is that some teams win twice. North Carolina won in 2009 and 2017. Same for Connecticut and Villanova and some of the other teams. Right now, this is still a function because our x's is our years, and every input, our x, has exactly one output. Each year there's one winner. The thing that would make this not a function is if we had 2 winners in 2009. If 2009 we say Kentucky also won, that's not a function. That doesn't make sense. So if you just remember that rule, every input has to have exactly one output, but it's okay for there to be multiple outputs, just like it's okay that multiple teams can win in different years. Let's keep that in mind and look at number 2. We have a set of ordered pairs. Which ones are the inputs? All right, so these are the inputs, and every input has to have exactly one output. There's a problem here. Can you spot it? If -2 is the input, it has 2 different outputs, and that's a problem. That doesn't make a function. For the next 3 questions, we're going to be looking at our graphs. How do we tell if a graph is a function? We can still apply our rule that every input has exactly one output, but it's probably easier to use your vertical line. So use your finger or use your pencil, put it on the screen and follow along with me. You're going to follow this line and you're going to make sure that it only touches at one point at a time. This line is good. It passed the vertical line test. It only touched at one point at a time. Let's look at the graph in number 4. I'm going to move my vertical line across it. You tell me whether or not you think it's a function. This is not a function. I can tell you because I'm looking at right here, and right here on this vertical line. It's touching at actually 3 points at a time. And as I move across the line, it's still touching at multiple different points as I go across. All right, try the last one by yourself and then press play when you're ready to check. Last one is a function because it does pass the vertical line test. As I cross through that linear function, it only touches 1 point at a time. We can also identify functions from equations, and they're going to follow the same rule. See if you can fill in the blank. For an equation to represent a function, every input will only result in one blank. Exactly one output. That's the rule for a function in a set of ordered pairs, a table, or a graph. So it's the same thing for an equation. The only thing different about the equation is that it's not necessarily giving you the inputs and the outputs. So one strategy you could use is to substitute different inputs in and see if you get different outputs. For example, looking at number 6, the equation is y equals x squared. To test whether this is a function, we would just come up with our own little table. We can put in a -2 in for x. -2 squared is 4. And we can keep trying it for different values in the table. What's 1 squared? 1 times 1 is 1, so that's a different output. And then 2 squared, 4. So it is a function. Every input does have its own output. It's okay that there's 2 y values, because if you looked at this as a graph, if you graphed this, the graph would look like this, and if you put a vertical line across it, it would pass the vertical line test. So one strategy is to substitute different input values in and see if the equation represents a function that way. I think it's easier to just go ahead and graph it. So I'll go ahead and show you the graph for this next one, and then you should go ahead and perform the vertical line test and see if this represents a function. This does not pass the vertical line test because if I move my line across it, you'll see at every point it's intersecting at 2 points. For it to pass the vertical line test, it can only pass through and intersect at 1 point at a time. Try this last one by yourself and then press play when you're ready to check. This is another graph that does not pass the vertical line test. If it's a circle, it's going to intersect at 2 places anywhere you look across this circle. So this is another one that is not a function. All right, the last thing you need to do today is go ahead and tell me which 3 of these represent functions and which 3 of these are not functions. Go ahead and try this now and press play when you're ready to check. All right, so number 10, 13, and 14 are not functions. They have inputs that have more than one output. And you can see that this graph does not pass the vertical line test because there's 2 points where it intersects on the vertical line. Number 9 is a function because each input does have its own output. It's okay that they're all the same output just because, like we looked at with the NCAA tournament, it's like Kentucky won every year. That's great. We love that. That's fine. It's still a function. And then as you can see, number 11 does pass the vertical line test, only touching 1 point at a time. Same thing for number 12. All right, guys, that's it. If you made it to the end of this video, I want to know what's your favorite thing to get out of a vending machine. Today we learned about identifying functions. Now you should be able to identify whether a table, ordered pair, set, graph, or equation represents a function. Now you should go ahead and go back to the calendar, put any other assignments you have left for the day. Let me know if you have any questions. Bye.